You ever wonder why we throw salt all over icy roads in the winter? I mean, it seems a little weird, doesn't it? You're adding a solid thing to another solid thing, and poof, the ice just disappears. Well, in this explainer, we're going to dig into the simple but kind of brilliant science that makes it all happen. So let's get right to it.
All right, let's kick things off with that classic slippery winter mystery. You know the scene. It's freezing cold, and you see those big trucks out there just dumping salt everywhere. But how? How does sprinkling a little salt make solid ice just melt, especially when the air is still below freezing? That's the puzzle we're going to solve right now.
Okay, to crack this case, we have to get into the real science behind it. And it all comes down to changing a really fundamental property of water.
So pretty much every pure liquid has what's called a freezing point. For good old H2O, pure water, that's 0 degrees Celsius or 32 Fahrenheit. Right at that magic number, the water molecules slow way down and lock themselves into that solid crystal pattern we know as ice. Seems pretty straightforward, right?
But here's the kicker. What if that freezing point wasn't some unbreakable law of nature? What if you could actually mess with it? That is the secret. We can actually trick water into staying liquid even when the thermometer dips way, way below its normal freezing temperature. And this is how it's done. It's a simple rule of chemistry. When you add an impurity, something like salt, to a pure liquid, like water, you actually lower its freezing point. So that salty water is going to stay liquid at temperatures where pure water would have frozen solid a long time ago.
Now, this whole phenomenon has a cool scientific name, freezing point depression. And the word depression here is perfect. It literally means we are pushing down that freezing temperature. Remember that name because it's the key to, well, everything else we're about to talk about.
So how do we know this for sure? I mean, how do scientists prove it? Well, let's pop on our lab coats and see how they measure this effect in a really controlled way. In the lab, the process is actually pretty simple. It's a three-step deal. First, you measure the freezing point of a pure substance. Step 2, you add a little something extra, what chemists call a solute. And step 3, you measure the new freezing point and see just how far it dropped. Easy enough?
And scientists can get super precise with this. They'll use a substance like lauric acid, for example, and record its freezing point. Then they'll mix in that impurity and measure the new, lower temperature. That difference, that drop, which they call delta T, tells them exactly how powerful that freezing point depression really is.
Okay, but why? Why does this even happen? What's going on down at the molecular level? Let's zoom way, way in and see how these little impurity particles are basically causing chaos. So, check this out. For any liquid to freeze, its molecules have to do something very specific. They have to slow down and line up in a super neat, orderly pattern, a crystal structure. Think of it like a marching band trying to get into perfect formation. That's exactly what pure water molecules are trying to do when they turn into ice.
Now here's where the chaos comes in. When you toss in something like salt, those salt particles just spread out all over the place, right in between the water molecules. They're literally getting in the way. It's like they're a bunch of clumsy tourists wandering right through the middle of that marching band's formation, making it impossible for them to line up properly. So because of all this interference, the universe has to try even harder to get that water to freeze. You have to pull way more energy out of the system. In other words, make it much, much colder to force those water molecules to finally overcome those pesky particles and lock into place. And the end result? A much lower freezing point. All right, so now that we've got the chemistry down, let's zoom back out and connect this to the real world. Because trust me, this simple principle is at work all around us, every single day. So, where does this stuff matter? Oh, everywhere. It's why we salt the roads, obviously. It's why we put antifreeze in our car radiators to stop the engine block from cracking in the winter. Heck, it's even the secret to making amazing homemade ice cream. That saltwater slush gets way colder than regular ice, which is what freezes the cream. And get this, the scale we use this on is just mind-boggling. In the United States alone, we dump more than 10 million tons of salt on our roads every single winter. That is an incredible amount of chemistry in action, all just to keep us from slipping and sliding around. So, you see, it's a really simple idea with a totally massive impact on our lives. From making sure our cars start in the morning to keeping the highways safe, it all comes back to that one basic rule. Adding stuff to a liquid makes it harder for it to freeze. It's just a perfect example of basic science doing some seriously heavy lifting in the real world. Kind of makes you wonder, doesn't it? If something as simple as salt can have such a huge effect on something as common as water, what other everyday ingredients are out there causing these powerful chemical changes right under our noses? What else is just waiting for us to notice?